All right, real quick, I already did this work, so I thought I'd run it by you and see what you thought. This is my proof of the product rule, and here is the product rule right here. So this is a great place to start. Here's the product rule, and whether or not you care about the proof of it or not, you really need desperately to have memorized the product rule. So we have a continuous function here, and the continuous function is f of x times g of x. And if we want to know what the slope of that function is at any x value, we would do this. We would say it would be f of x times g prime at x plus g of x times f prime at x. This is what you should memorize. So let's be clear about what our expectation is here. So this you memorize. So memorize this, and then let's just walk through this really, really quickly. So here it is. This is my proof of this. I'm going to use the limit process to try to prove this a little bit. So using the limit process, I'm suggesting to you that the derivative of f of x times g of x is the same as the limit as x approaches 0 of f of x plus change of x times g of x plus change in x minus f of x times g of x all over change in x. And how did I get that? This is just the limit process here. So this is just limit process. So limit process, and you should be pretty good at this. I want to reiterate to you that the proof of this is not necessary on the AP Calculus exam. So if your intention of watching this video is to prepare for that, this is probably not necessary, and there may be a better video for you to watch. For the rest of us, let's kind of go through this proof really quickly. If you're in college, your professor does expect you, he or she does expect you to be able to prove this rule. So here's my attempt here. So we set this up, and then just a really quick little trick here. And if you just remember that the multiplicative identity is 1. That is to say that 1 times any number does not change the identity of that number. And there's also something called the additive identity, and the additive identity answers the question, what number can I add to any number and change nothing? And the additive identity is 0. So if you look at this in blue here, took minus f of x plus change of x g of x. So there's the minus plus f of x plus change of x times g of x. And these are opposites, so I really added nothing, right? These two pieces together, 0. So why would we do this? It's a clever little piece of math, and it's used for factoring, and I'll show you what I mean in a second. So when we look at this first part right here, I'm looking at this right here, you see that we have a factor of f of x over here, and we have a factor of f of x here. So we're going to factor that out. So there's that f of x, right? And that would leave us g of x plus change of x minus g of x. And there's that, isn't it? All over change in x. Okay? And then if we look at this second piece, let me slide this over a little bit so you can take a better look at it. So now I'm over here. This plus sign right here is this one here. And here we have a g of x here, and we have a g of x here. So we're going to factor out g of x, which would leave us, wouldn't it? That would leave us this f of x right here, f of x plus change of x here, and this f of x here, wouldn't it? And this negative sign right here is this one right here. Okay? So when we factor that out, we'd factor out a g of x, and it would leave us with f of x plus change of x minus f of x over change of x. Believe it or not, we're almost done with this proof. This is my 3-minute proof, I think. So we look at this for a second. What I do need you to kind of buy with me is that because this is a continuous function, f of x plus change of x is just, well, another f of x, isn't it? So by definition, it is f of x. More by definition we have here, because remember we're trying to prove the product rule, that g of x plus change of x minus g of x all over change in x, by definition, if we look at the definition in limit process, this is the derivative. So I'm going to name it the derivative. This, by definition, is g prime at x, and therefore it's g prime at x. This plus sign right here is this one right here. We know where this g of x came from because it came straight, we know where this g of x came from. It came straight down from here. And again, I'm asking you to buy the idea that by definition, this thing right here, by definition, is f prime at x. And therefore, when we put all this back together, we do indeed get the product rule. Right? So that's my proof. I hope it was interesting? Something. Okay, you guys, keep up the good work. Vaya con Dios. Go with God.